So today we'll be deriving the sum and difference for the angle identities for sine, cosine, and tangent. So let's get right into it. Let's make this an angle of alpha. Oh. Let's make this a 90-degree angle. Let's make this angle beta. And let's make these all 90 degrees. And now we can start. This angle here must be 90 minus alpha, because the sum of the angles in a triangle equal 180. So 90 minus alpha plus alpha is 90, plus another 90 is 180. So yeah. And this angle here must be alpha, because a straight line also has an angle of 180. So these three angles right here must add up to 180. 90 minus alpha is 90, plus 90 here is 180. For the same reason here, this would also be 90 minus alpha, and this would be 90 minus beta. This line must have a degree of 180, so these three angles must sum up to 180. That means this is alpha plus beta, because when we sum these, we get 180 minus beta minus alpha plus beta cancels these out, so we just get 180. And finally, alright, and let's make this 1. Now, look, sine theta in general just equals opposite over hypotenuse. Now, we want to find the length of this. This is op. This is the opposite side. So op equals sine theta times hypotenuse. And the hypotenuse is just 1. We're making it 1, so it's simpler to do the calculations. So sine theta here is just sine alpha plus beta. And times 1, well, it's just this. That's op. And the same reasoning for cosine. Cosine is adjacent over hypotenuse, but since the hypotenuse is 1, we multiply it by the other side. We just get this. Oh yeah, I'm just going to write it down for you. Equal. And this is the adjacent side, remember. Adjacent times 1. Now, what about this? Well, for the same reason, hypotenuse is 1, then this is going to be exactly cos beta, and this is going to be exactly sine beta. Now, this is where things get tricky. What is the length of this? Well, its angle is cos alpha, right? This cos alpha. So cos alpha equals adjacent over hypotenuse. But the hypotenuse is cos beta, so cos alpha equal adjacent over cos beta. That means the adjacent side equals cos alpha times cos beta. And that's where we get that here. Using the same reasoning, cos beta times sine alpha for this side. Now, let's also use the same reasoning here. This would be cos alpha times sine beta. Wait, no, sorry. This would be, cos alpha, cos alpha times sine beta. It's the hypotenuse times the cos alpha of this. This will be sine alpha sine beta, because this angle is alpha here. Now, I want you to notice something. This entire side here is sine alpha plus beta. But sine alpha plus beta also equals cos alpha times sine beta plus cos beta times sine alpha. They cut off here. So these two sides, when summed, equals that. So we know our first identity to be this. Cos alpha plus cos beta sine alpha. Now, what about this side? Well, cos alpha plus beta equals this entire length here minus that. So it's going to be cos alpha times cos beta minus sine alpha times sine beta. And then with this knowledge, we can also derive the tan formula. Wait. let's go here. Tan alpha plus beta just equals sine alpha plus beta over cos alpha plus beta. And then we can use what we found here. We split it apart and write it as this. And now to simplify things even more, let's divide everything by cos alpha, cos beta. We're going to divide the numerator and the denominator by cos alpha and cos beta, so we get the same, or yeah, they end up being, yeah, okay, that's hard to explain, right? So this divided by that is just 1 minus, that's just going to be tan alpha times tan beta. And when we divide the numerator by the same thing, well, if you divide the numerator and denominator by the same thing, it's going to end up being exactly like the previous result, but just, written differently. So let's take some number 2 divided by 4. Well, if you divide the numerator by 2 and the denominator by 2, you get something that looks different, but is actually the same as the previous. So if you divide the denominator and numerator by the same thing, you're going to get the same thing. That's what I was trying to explain earlier. So if you divide the numerator, cos alpha cancels out to 1, and this just ends up being tan beta. Divide that by that, and cos beta and cos beta cancel out to 1. This is just tan alpha. And that's for the sum angle identities. Now, what about the subtraction? I'll see you in the next video. Now we're going to derive the subtraction identities. Keep these formulas in mind. I'm gonna write it down for you. So let's write down here, sine alpha plus beta equal sine alpha cos beta plus cos alpha sine beta, and so on and so forth. And we're going to derive the subtraction identities from here. All right, let's begin with sine alpha. So if sine alpha plus beta can also, well, we can rewrite, or no, let's start off with sine alpha minus beta. This can be rewritten as sine alpha plus negative beta. Now let's see what that does for us. So we get alpha is still positive, beta is negative though, so we get cos negative beta plus cos alpha and sine negative beta. Now, if you learned your unit circle, cos theta just equals cos negative theta, because on the unit circle, if let's say there's an angle here, a negative angle would just bring it over the x-axis. Now x is always going to be positive on the right side, so if you flip it over to x, it's just going to keep positive. But for a sine theta it takes into account the y value. So if you flip over the y value, it will become negative. So sine negative theta equals negative sine theta. Now if we know these identities, just cos, we can this is just cos beta. So sine alpha minus beta. Let's get rid of the plus sign. Sine alpha cos beta. But however, this sine negative beta becomes negative sine beta. So this is the first addition identity. I took the negative sign in front to get this. Now we can do the same thing for cos alpha plus beta. We do this plus negative beta. And let's see here, what would that equal? Well, we plug in things from here. Alpha will remain positive. And a negative beta doesn't mean anything. Cos negative beta just equals cos beta. Negative sine alpha. This will change signs. Or no, actually it won't. This will remain positive because alpha is positive. But this will become negative. This will become negative sine beta. Now a negative and a negative makes a positive. So we get this. Times sine beta. And finally for tan. Well, a negative angle for tan also works like sine. Because so tan theta equals sine theta over cos theta, right? So let's say, so in this scenario, sine theta and cos theta are both positive, but if you flip it over the x-axis, sine theta will become negative and cos theta would become would still remain positive. So tan theta equals negative tan theta. It's similar to sine theta, or tan negative theta, sorry. Tan negative theta is negative tan theta. So with this in mind, we do this. Tan alpha plus negative beta. Well, alpha is just positive. Beta becomes negative because tan negative beta becomes negative tan beta. And with this becomes negative, and the negative cancels out with this negative here. So we get 1 plus tan theta tan beta. Alright, and that's for the differences. So the key into proving this is just to know their negative angle identities. And that's all. Thank you.